Welcome to our video introduction to the BayesMobile app. Since you are interested in BayesMobile, you are quite likely familiar with Bayesian Networks. However, if you do not know what Bayesian Networks are, we encourage you to watch our Bayesian Network introduction video from this channel. You can find links to other tutorials on our website and in the video description. After watching this video, you will be familiar with the basic functionality of BayesMobile. BayesMobile is a mobile application that allows you to use Bayesian networks created interactively in GeNIe or programmatically in Smile. BayesMobile is available in the App Store. The download link is included in the video description. The basic version of BayesMobile contains 3 models, created by BayesFusion and other authors. Built-in models demonstrate the basic utility of BayesMobile through examples, such as diagnosing a car fuel system, diagnosis of liver disorders, or evaluation of a loan applicant. By making one in-app purchase, you open up the possibility of adding your own models. You can import them directly from your mobile device or from a BayesBox instance. To do this, select Use Your Model in the main application menu and follow the instructions. In addition, application data will be synchronized between your devices. For example, you can start your work on your iPhone and finish it later on your iPad. In our introduction, we will use the engine fuel system model, one of the built-in example models. The Explore button allows you to view a graphical representation of the model. You can see how nodes are interconnected. In this view, you can also examine the marginal probability distributions over various model variables. To view them or to mark their observed value, just open the collapsible panel. In the engine fuel system model, 2 nodes are marked as false: fuel delivery system and fuel filters and bypass value. Selected states of these nodes are at the center of the diagnostic process. The author of the model also predefined 3 observations related to fuel pressure, assuming that there is no fuel pressure drop, node state absent, and that the fuel pressure is neither high or low. The main part of the application is the diagnostic view, which consists of 4 tabs. The False tab contains probabilities of events chosen by the model author. The Unobserved tab lists all observable, yet not observed nodes. The Observed tab lists those nodes whose states have been already observed. The Cases tab contains a list of diagnostic cases, that is, collections of observations stored for future use. The user can return to any of these cases to continue diagnosis. In the Unobserved tab, nodes are sorted by their diagnostic value. The higher the value, the greater the variable's potential to change the probabilities of the nodes present in the False tab. Suppose that in the car being diagnosed, the fuel system has not passed visual inspection and the fuel system pressure test under load failed. To observe these values, let us set the values of both the visual inspection of the fuel system and the load test fuel pressure nodes to fail. These observations have led to a significant increase in the probability of a defect in the fuel system. Previous observations listed in the Observed tab can be modified. Let's assume that the fuel system looks good and the load test has not yet been performed. After changing these observations, the probability of a defect in the fuel system decreases significantly. If you have to interrupt the process for any reason, you can save the current observations in the Cases tab. After clicking the Create New Case button, the observations made so far will be saved to a new case, and this new case will be the focus of diagnosis. This concludes our BayesMobile introduction video. You can find out more information online at BayesFusion.com. We invite you to watch our other tutorials and subscribe to our channel.